right, the big topic we had to finish up in 6.3 is called the reference angle. And here's what the reference angle means. I want another clip. If you have an angle and the angle is not acute, and the angle does not end up on one of the axes. So it's not enough just to say obtuse, because I don't mean like 180 degrees, for example. So if I have an angle like such, and I measure this angle this way, somebody give me a reasonable number for what that angle might be.
200.
That might be 200, because it's a little bit more than 180 degrees. So this might be 200 degrees. The reference angle means the acute angle using the x-axis as one side. So it's always the x-axis, never the y-axis. So in this case, the reference angle would be that angle right there. I go from the x-axis to my angle. What measure would that angle be? Why 20 degrees? Because it would be 180 and some more to get 200. That would have to be 20 degrees. Now, what's important about the reference angle? True, it shows me that angle. Well, here's what I have. I'm going to draw myself a nice little right triangle here. So I have a nice right triangle. So in a right triangle, is it pretty easy to talk about sine and cosine and tangent? Yeah. So what can you tell me about the sine of 20 degrees in relationship to the sine of 200 degrees? Well, what I'm getting at is the sine of 20 degrees is going to be a positive answer, isn't it? What about the sine of 200 degrees? It's going to be negative because it's in quadrant number 2. But what about the sine of 20 and the sine of 200? They're going to be exactly the same, except this one's a positive number and this one's a negative number. So the sine of 20 degrees is exactly the same as sine of 200 degrees, except we need an additional minus sign in there. Because sine of 20 is positive, sine of 200 is negative. How about cosine of 20 degrees and cosine of 200 degrees? How would they be related? Well, again, what can you tell me about cosine of 200 degrees? Is it positive or negative? It's negative. And what can you tell me about cosine of 20 degrees? Positive. Why do I get the same number, except again I would need an additional minus sign? How would I figure out the sine and cosine of 20 degrees? Let's say we have this point right here. What's a reasonable value for that point? Negative 5, negative 3 maybe? Okay. And then the radius would be something, we would figure it out. So, this 20 degree angle really lives over here. It's going to have this point, 5, 3. So all of its values are going to be positive, but over here when I'm doing sine and cosine, I'm going to get negative answers. So they're going to be exactly the same, just one's going to be positive and one's going to be negative. How about tangent of 30 degrees or tangent of 20 degrees? How is it going to relate to tangent of 200 degrees? No? They're both positive. So they're exactly the same. I don't need a little minus sign there. All right, so here's a typical question you might be asked. I want you to tell me theta is 150 degrees. I want you to tell me the sine, cosine, and tangent of 150 degrees. The first thing I would do is I would draw myself a picture. Where's 150 degrees? It's in the second quadrant because it's a little bit less than 180 degrees. So here's 150 degrees. So what's the reference angle?
30 degrees.
The reference angle would be this one. Why is it 30 degrees? Because 150 plus 30 would get me to the axis. That would be 180 degrees. So the sine of 30 degrees, the sine of 150 degrees is exactly equal to the sine of 30 degrees, except I might need to be careful of pluses and minuses. In quadrant number 2, is sine positive or negative? Positive. So it's exactly equal to, isn't it? What's the sine of 30 degrees? 1/2 is the correct answer. The cosine of 150 degrees is exactly the cosine of 30 degrees, except I got to worry about my pluses and my minuses. In quadrant number 2, cosine is negative. So cosine of 150 is going to be the same as cosine of 130. Cosine of 150 is going to be the same as cosine of 30 if I put a minus sign in front of it. Cosine of 30?
Square root 2.
1/2? Negative 1/2?
No, square root of 3 over 2.
Square root of 3 over 2? This is also one of my favorite games, by the way. Somebody will give me the right answer, and I can quite often convince them they're wrong. I know, it's mean, isn't it? You got to memorize it. You got to know it cold. And the only way you can know it cold is for me to torture you with it. It is negative square root of 3 over 2. Cosine of 30 degrees is square root of 3 over 2. Finally, tangent of 150 degrees would be exactly the same as tangent of 30 degrees. Do I need a minus sign?
Yeah.
Yes, why? Because tangent is negative in quadrant number 2, so that's a negative. Tangent of 30 degrees. Final answer is negative root 3 over 3. Tangent of 30 degrees is root 3 over 3, and I need that minus sign.
Does it matter when the minus sign goes on? Because
Well, my goal is to know the tangent of 150 degrees, so I know that one has to be negative. I mean, you're correct in saying negative tangent of 150 degrees is the same as tangent of 30 degrees. So it doesn't matter where the negative sign goes. It's just that when I write my final answer, if I want to know the tangent of 150, my final answer has to have a negative sign in front of it.
yeah.
Right. Okay? All right, how about theta equals negative 225 degrees. I want to know sine, cosine, and tangent of negative 225 degrees. I begin by drawing myself a picture. Where is negative 225 degrees? Quadrant 3? Quadrant 2? Quadrant 1? Quadrant 4? That's all of them.
2.
Why 2?
Because you're going.
I'm starting here and I'm going backward. So this would be negative 180. So I've got to go some more. So my angle is this one. Negative 225 degrees is there. And so what's my reference angle? Why 45? Correct. I've got to go back to here. I've got to go back to the 180 degrees. To go back to the 180, I would have to add 45 degrees. So my reference angle this time is 45 degrees. I'm once again in quadrant number 2. Okay, so here's my answer. Sine of negative 225 degrees is the same as sine 45 degrees. Do I need a plus? Do I need a minus sign? No, why not? Sine is positive in quadrant number 2. Sine of 45 degrees is square root of 2 over 2. Cosine of negative 225 degrees is the same as cosine of 45 degrees. Do I need a negative sign? Yes, because I'm in quadrant 2 and cosine is negative in quadrant number 2. That's negative cosine of 45. Also square root of 2 over 2. And finally, tangent of negative 225 degrees is tangent of 45 degrees. Do I need a negative sign? Yes, tangent is negative in quadrant number 2. So that's negative 1. Tangent of 45 happens to be 1. Questions on that? All right, my last question with reference angles is this. Here's my angle theta, and I'm going to give you a point on this angle right here, point on this ray. Again, somebody give me some reasonable numbers here. 2 and 4? No, 2 and 4 would be over here. Negative 2, negative 4? That's reasonable. Your scaling's a little strange, but I'll go with it. I'm going to call it about negative 4, negative 3. What would the tangent of theta be? How do we find tangent again? Let's see, sine was y over r, cosine was x over r, tangent is y over x. So that's going to be negative 3 over negative 4, that's 3/4. What if I wanted to know what this angle is? How would I get theta all by itself? How do I get rid of the tangent? Inverse tangent. So theta would be inverse tangent of 3/4. So I'm going to grab my calculator. I'm going to type in inverse tangent of 3/4. Inverse tangent of 3/4. And my calculator says the answer is 36.9 degrees. Excellent. Clearly that angle is not 36.9 degrees. Why not? Because it's in quadrant 3, it's got to be bigger than 180. What did my calculator actually give me? When you use that tangent inverse button, the sine inverse button, the cosine inverse button, your calculator will give you the reference angle. So what the calculator gave me is that angle right there, 36.9 degrees. So my final answer would be, I'd have to add 180, 216.9 degrees. Why does the calculator give the reference angle? Pretty much. The calculator, when you type in theta equals tan inverse of 3/4, the calculator doesn't know if you want the answer in quadrant 1 or if you want the answer in quadrant 3. So by default, it's always going to give you the answer in quadrant 1. And if your answer is in quadrant 3, then you've got to figure it out. Okay, so be careful of that. That tan inverse button, the sine inverse button, they'll always give you the answer in quadrant 1. They will always give you the reference angle. If your angle is in a different quadrant, you have to do a little bit more work. Not a lot, but a little bit. All right, the last thing we need to talk about in this section is bearings. Bearing. What's bearing mean? Any pilots in the room?
Something that can go in towards like a certain direction or something.
Yep. So if you're a pilot, how do you measure your bearing? How? So if the radio tower calls and says, turn 15 degrees, what are they telling the pilot to do? Turn in which direction? To the right. If you're a pilot, the way pilots and naval officers measure things, they measure everything off due north. So if a pilot is told turn 15 degrees, the pilot is being told turn towards the east 15 degrees like so. So we would normally call that what angle? We would traditionally call that 75 degrees. Okay, so you might have a question like this. A plane flew for 200 miles in a bearing of, somebody give me a nice angle, $30 degrees. That's kind of a boring angle, but we'll go with it. 30 degrees. How far north and how far south? No, not south. How far east has the plane flown? Okay, so what we do is we draw ourselves a picture. Let's see, we were told the bearing was 30 degrees, so that means that angle right there is 30 degrees, which means this angle, the one we're going to use, is 60 degrees. And we're told the plane flew for 200 miles. So what's that?
That would be the radius.
That would be the radius. So right here, this distance R is 200 miles. We want to know how far north he flew. That would be that distance. That would be north. And how far east would be that distance. So if I know my angle is 60 degrees and I know my radius is 200 miles, how am I going to find my north? I have this angle. North is the opposite, and 200 is the hypotenuse. So what uses angle, opposite, hypotenuse? Sine. So sine of 60 degrees would be north. I'm going to call north y because that's up and down, I suppose. Y over 200. So y would be 200 sine of 60 degrees. Sine of 60 degrees is? Square root of 3 over 2. So that's going to be 200 times square root of 3 over 2. Now, in this case, I do think it would make sense to type that into my calculator and get a decimal approximation, because I want to know how many miles he went. So I would actually type that in. 200 times square root of 3. I'm having trouble typing today. Divided by 2. That's about 173 miles. So that would be 173 miles north. And how am I going to figure out the east? I could use cosine, absolutely. Cosine of 60 degrees is x over 200. So x is 200 cosine 60 degrees. Cosine 60 degrees happens to be a very nice number. 1/2, so that's 200 times a half. That's going to be 100 miles east. So the pilot has flown 173 miles to the north and 100 miles to the east.